but for this course I'll be focusing mostly on the commands library because it is more important to learn. We will have one project that will use both the OpenMaya API briefly, as well as the PyML API for the entire project. With this covered, let's continue on to our next projects. We need to affect objects inside of Maya. We will primarily be affecting attributes on these objects. These attributes are often referred to by the object name, followed by a dot, and then finally followed by the attribute name itself. Every object in Maya is actually a node. You can view this inside of the node editor, but I'm going to show you a simplified diagram. Every node has several attributes that we can edit. We can access these attributes in our scripts by using the object name, dot, and the attribute name, but on the node, they appear as objects called plugs. Plugs can have values set on them, and that's what we often do with scripts. We can also key them, but we can also create connections between one node's plugs and another's. This is how most, if not all, objects inside of Maya interact with each other. It's also how we'll primarily be interacting with objects inside of Maya, by changing these values using our scripts. In this video, we'll be going over the two different Python versions in the wild. The two current versions of Python are Python 2.7 and Python 3.5. Python 2.7 is the latest in the Python 2 series. Python 3.5 is the latest version in the Python 3 series. Python 2 will see no more active development outside of simple security fixes, and will receive an end of life in the next couple of years. The Python Foundation has decided that Python 3 is the way forward. Now, why are there different versions of Python? Well, this is because Python 2 and Python 3 have many breaking changes between them. This means that Python 2 code isn't guaranteed to run under Python 3. Additionally, Python 3 has many new features that cannot be used by Python 2. This means that even though the language is very similar between Python 2 and Python 3, and in most instances you cannot even tell the difference, it does mean that Python 2 and Python 3 are not guaranteed to be compatible with each other. Maya originally launched with Python in Maya 8.5, with Python version 2.4.3. In Maya 2009, they upgraded the Python version to 2.5, and in Maya 2011, they upgraded again to 2.6. Finally, in Maya 2014, they've upgraded Python to Python 2.7. This is the most recent version of Python in the Python 2 series, and will likely be the last. The visual effects industry has decided to stick with Python 2.7 as long as it can. This is because of significant investment in the Python 2 ecosystem, which would be hard to port over to Python 3. The VFX platform has decided that Python 2.7 is the version of Python that all software should be using. Therefore, whenever we are developing for Maya, we'll be using Python 2.7. In this video, I'll go over how to save the script and then source it back in. So we'll go to File, Save Script. This brings up the document browser. The documents are stored in different locations on different operating systems. But for Windows, it's under Documents, Maya, your Maya version, and Scripts. If you're using Mac OS or Linux, I'll make sure to mention them in the video. I'm going to save the script as object renamer example.py, and I'll hit save. Now that I've saved the script, I can get rid of this. Now that the script is gone, I can say File, Load Script, find it again, and it'll load it into the current tab. Alternatively, I can say File, Source Script, and instead of loading it in, what it'll do is it'll execute it immediately. This isn't ideal because, as you can see, it's changed all the names of my objects and I didn't want that. In our next video, I'm going to go over how to compose our script into functions that won't run immediately but will be available for us to call easily. One last way to call a script is because it's saved in our scripts directory, we can say import object renamer example. And what it will do is it'll import that just like we imported the Maya commands library. And now the script has been imported into Maya. But unfortunately, importing also executes the script, causing it to run yet again. Again, in our next few videos, we'll go over how to compose it into functions that will only run when called. For this project, we'll be learning how to create a controller library using Qt. Our controller library will be flexible and will support thumbnails. We can import any of the objects that we save out. And we can also create any new objects we want. In this case, I will save this as the test. And when I hit save, you'll see that it shows up inside of our window. We'll learn how to save data out as JSON files, as well as load them back into our UI. We'll be using Qt, provided by PySide2 inside of Maya 2017, and PySide in previous versions of Maya. We'll go over the differences between Qt 4 and Qt 5, as well as the differences between PyQt and PySide, and PyQt 5 and PySide 2. I'll also be going over a popular Qt library that's used by Disney, Weta, Sony ImageWorks, and more that will help us write code that can be used by Qt in both Maya 2017 and previous versions of Maya. In the next video, I'll do a brief introduction to Qt and the different versions of Qt used inside the different versions of Maya. Before we continue any further, I'd like to show you how you can get information about each of Maya's commands. Inside of Maya, you can go to the Help menu, go to Maya Scripting References, and click on the Python command reference. This will open the Autodesk documentation, and it will list every single command that Maya has to offer. I want to look at the parent command, and over here I can see that the parent command takes two objects, the child and the parent, and another series of parameters. Scrolling down, you can see each of the parameters with its long name and its short name, as well as a type. And scrolling down even further, we can find documented examples of how to use it. Back in Maya, we can also find help inside of the script editor. For example, if I want help on the parent command, I can select it, right-click, and go to Quick Help. This will list all the flags with their short names and their long names. Additionally, I can also enable auto-completion. I can go to this menu, and I can enable command completion and show tooltip help. Now when I type, it will try and auto-complete for me. And when I'm inside of a command, it will list all the flags that it takes. Personally, I like to disable this because it can get quite busy inside of Maya, though I leave it enabled inside of PyCharm. If you're ever stuck, the documentation online can be a great help. Maya's help features are limited to only the Maya libraries, but you'll often need to look up information about Python itself. The python.org website has great documentation on everything inside Python. For example, this is a page on all the variable types. You can also access help inside of Maya. For example, if I run help and give it an object, it will print out all the information about that object type. In this case, I'm looking up the help documentation for a list. Sometimes you already have an object defined, and you want to look up what you can do with that object. In that case, you can use the dir command. What the dir command will do is it will give you a list of all the objects and attributes that are associated with the object you give it. In this case, we can see that the list object assigned to the variable a has all these functions inside of it. And we can see that we can append to it, we can count it, insert, index, etc. Both of these functions are very handy, as you can look up information on the fly while you're writing a script. To begin our course, we'll need to get a list of the items that we'll be operating on. In my scene, I have 2 join chains, a cube, and a group, but you can have anything you want. First of all, we need to get the Maya commands library again. We'll say from Maya, import commands. Inside of the commands library is a list function. If we run this, and I'll print out the output, you can see that it gives us back a list of all the objects in the scene. At the very end, you can see the objects that we're talking about. But we also get a bunch of objects that I don't actually care about. These are hidden objects inside of Maya. So what we can do is tell the ls object to only use the selection that we want. So let's look up the documentation for the ls command. If we double click on it, and then right click, you can select command documentation. This will open up the browser for the ls command. Down here you can see the selection parameter, and if I click it, it'll take us to the documentation for the selection parameter. You can see that the long name is selection, and the short name is SL. It is of type Boolean, which means that it can be either true or false, and if it's true, it will list objects that are currently selected. So back in Maya, now let's give the ls command the selection parameter. So we say selection is equal to true, and now you can see that it'll only list the object I have selected, in this case, joint 1. So let's store this inside of a variable. You'll say selection is equal to commands.ls selection is equal to true. But what if we don't have anything selected? If I now print out selection without anything selected, you can see we just get an empty list because nothing is selected. And if I redo it with something selected, we'll get back that object. If we don't have something selected, I want to do something different. So we'll be introduced to the if statement in the next video. In this video, we'll be learning about the if statement. The if statement lets us say that if something is true, do something else. And the syntax is pretty simple. What we're saying is if the statement is true, only then will we do this. And you can see that the things that we'll do are indented. In Python, this is called a scope. The scope of this logic is this if statement. Everything underneath this if statement that is indented will only run if this if statement is true. And if it's not indented, then it will run regardless of whether this if statement is true. So back in Maya, let's write our if statement. So we say if the length of the selection is equal to 0, we'll get a new selection. First of all, let's look at the double equal symbol that we used. The single equal symbol means that we're assigning something. The double equal symbol means that we're comparing something in value. So we're going to say, if the length of the selection is 0, then let's get a new selection. So we'll say commands.ls, and I'm going to use 2 parameters that I'm going to introduce shortly. I'm going to say dag equals true, and long equals true. If we go back to the documentation and look at long, you can see that it takes a boolean. And you can see that if it's true, it'll return full path names for DAG objects. Now why am I doing this? Back in Maya, you can see that I have joint 1 and joint 4, but underneath joint 1 I also have another joint 4. It's sort of like at work when you have two Johns, and if you say hey John, neither of them is sure which one should respond. In Maya, if I was to say hey joint 4, both joint 4s will try and respond and it will cause an error. The long parameter means that we get the full path to the object. So we'll get joint 4 and know that it is a child of joint 1, whereas this joint 4 has no parent. Now let's look at the DAG parameter. Back in the documentation, we can scroll up to DAG, and you can see that it's actually called DAG objects, but I've used a short form DAG. This lists DAG objects of any type. What this means is that we'll only get objects that are listed in the outliner, and none of the hidden objects inside of Maya. So if I now print the selection after this if statement, and notice that my print statement is outside of the if statement. That means that whether or not the if statement runs, this print will still run. So now if I run this, you can see that it's only going to use the selection that I have, because I have more than one object selected, therefore my if statement is false. If I select nothing, and now I run, you can see that it's listed every object in the outliner. This is because the if statement is false and does not run. This is because the if statement is true. The length of the selection is 0. Therefore we will get the new selection which will list everything in the outliner. But you can see that the order of the list isn't particularly useful to us. The problem is that if we rename joint 4, but it has the full path which is joint 1, joint 4, that is alright. But if we rename joint 1, the path to joint 4 now changes. This means that we can no longer find joint 4. Therefore we need to sort it with the children first and the parents at the end. Back in Maya, what I'm going to do is I'm going to sort the selection. So before this print statement, I'm going to say selection.sort, because selection is a list and it has a sort method. If I now print selection, you can see that it's actually sorted the list, but that it's sorted them alphabetically. That's the default behavior for sort. This isn't useful for us. Instead we need to tell sort to use the length of the objects. This is because the children will have a longer full name than the parents, because they're deeper down. For example, joint 4 will include joint 1 in its path, whereas joint 1 will have nothing, because it is the topmost object. So we'll tell the selection.sort to use the length as the key for sorting, so we'll say key is equal to length. And now if you run this, you can see that objects are sorted from shortest to longest. Again, that's not what we wanted. We wanted the opposite. We can also tell sort to reverse it. So we say reverse equals true. And now if you run it, you can see that the longest objects are at the end, and the shortest objects are at the other end. What this means is that the children will be acted upon first, and then the parents, thereby not affecting the path to the children. In the next video we'll go over for loops and how we can go through all the items in the list and do something with them. In this video we'll be introduced to the for loop. The for loop says that for an item in my list, do something with this item. Again, you can see that the logic is indented. This means that it will only run in the scope of the for loop. Anything outside the loop is unindented because it will run outside of the for loop. The syntax of the for loop says for item, where item is the name of a temporary variable. An item can be called anything you want. Inside my list, where my list is the list that you want to loop to. We're going to do something with that item. Now back in Maya, what we're going to do is we're just going to go through every item inside of our selection and find the short name for this item. So you're going to say for obj, short for object, in selection, which is the list that we have of all our selected objects. We're going to say print obj. And now if I run this, you can see that it prints out our names. The names are kind of long at the top. They have this pipe symbol to show the path of the object. What we want is to split up the string by the pipe symbol. Fortunately, obj is a string object, so we can say print obj.split, and the split operation by default works on spaces, but we need to tell it to work on the pipe symbol instead, so we give it the pipe symbol instead of quotation marks. And if we run this now, you can see that each object is now a list of every word split up by the pipe symbol. But we don't want every single word, we just want the last word. So since it's a list, we already know how to access objects within it. We use the square brackets and give it a number. But the problem is that each of these lists is of variable length. Some of them are only 1 object long, and some are 4 objects long. Fortunately, Python lets us iterate backwards through a list as well. So if we give it -1, it means that it will take the very last object inside of the list. So now if we run this, you can see that we only have 1 word, and the word is the last word inside of the list. We will take this, and we'll assign it to the variable short name. In the next video, we'll look about fleshing out this for loop by renaming these objects according to their type. I'd like to take a pause here and talk about a different kind of loop, the while loop. The while loop is very similar to the if statement and the for loop combined. What it does is it says, if this statement is true, keep doing this action till the statement is no longer true. Additionally, you can exit the while loop, or even a for loop, by saying break. Break tells Python to break out of the loop that it's currently in. While loops are powerful for when we don't know how long an action should run for, but we know when we want it to stop. We'll be covering while loops later on in the course, but I thought it was useful to mention it now, so that you're aware of them if you see them in any of the documentation. In this video, we're going to try and get the object types of each of the items in our list. We'll start off by saying print command.object type of the object in this list. And when we run this, with this cube selected, it will give us back transform. Now you may be asking, why is it a transform when it's clearly a mesh object? Well, in the outliner, if we right click and say shapes, you can see that every shape is actually a transform and a shape. This is just how Maya represents its objects. So let's get rid of the shapes for now. And we have to actually find the children of the transform, and then get the object type of the children. So let's clear this out, and let's fetch the children. We can do this with a command called listRelatives. And let's store this inside a variable called children. Inside of listRelatives, let's give it the object that we want to get the relatives for. Then let's tell it that we only want the children. Let's also tell it that we want the full path to each of the children. If I run this now, and let me print out children so that we can see what we get. If I run this now, you can see that this shading group, which is selected has no children. But if I select pcube1, you can see that we'll get the pcube shape 1 instead. If I choose this empty group, you can see that instead of a list, we get the none object. This is kind of annoying in Maya, because even though the command says list, when it has nothing to give us back, it gives us none. This means all our code would need to check if it's none or a list, but we can do a simple trick. At the end of this command, you can just type OR and 2 square brackets. What we're saying is that if list relatives is empty or none, then let's just make it an empty list, which is denoted by the 2 square brackets. So no matter what we do, we're always sure that children will be of object type list. So let's get rid of the print children and get the object type of the child. The problem is we only want to get the object type of the child if it's the only child underneath the parent. So we'll use an if statement. We'll say if the length of the children list is equal to 1. Again, note that we use 2 equal symbols to compare instead of 1 equal symbol to assign. We'll get the child from the children's list, and we'll get the first child, which will hopefully also only be the only child, by saying 0. Again, remember that lists start counting from 0 instead of 1. And we'll say the obj type variable is equal to commands or object type of the child. Otherwise, we'll say that obj type is equal to commands or object type of the parent, in this case obj. Over here you can see the else statement. The else statement is run if the if statement is not true. So if the length of the children is less or more than 1, we'll run this statement here instead. But if the length of the children is 1, we'll run this. This lets us set up conditions for how the code will run based on values at runtime. Now that we have the object type, we can print it out and see that if I select the cube, I will get mesh. And if I select the joint, I will get joint. And if I select the empty group, I will get transform, because that's what it is. In the next video, we'll go over more complex if statements using the object type to determine what the object should be renamed to. Now that we have the object type, let's figure out what our suffix should be. So we can use a few if statements to figure this out. So we can say if obj type is equal to mesh. Again, note the double equal symbol instead of the single one. We'll say suffix is equal to geo. Otherwise, if the object type is equal to joint, we'll say the suffix is equal to joint. This is the elif keyword. Like the else keyword, it will only run if the if statement is false. But unlike the else statement, it provides another statement to check. In this case, we're saying if the object type is mesh, then the suffix will be geo. If the object type is not mesh, we'll do the next check to check if the object type is joint. If it's not joint, then we'll continue on down the chain of if and else statements. So following this, we'll have another elif, and we'll say if object type is equal to camera. I don't actually want to do anything if it's a camera, so I can say print, skipping, camera, and I can say continue. And what we're doing with continue is we're telling the for loop to continue on to the next item and not perform any of the other logic in this for loop for the current item. Next, we'll have the else statement, which will only run if all the other statements in this if, elif, and else tree are false. We'll say, if none of these other statements are true, the suffix is equal to group. Finally, we say the new name is equal to short name plus underscore plus suffix. Because both short name and suffix are strings, we can add them with the plus operator, and this will create a string combining them. If I say print new name and run it, we can see the pcube1 will be renamed to pcube1grp because it is a group. But if I use pcube1 that represents a cube in here, and then run this, you can see that it will be renamed to geo. Now, let's do the actual rename. We can say commands.rename, we give it the old name, in this case we'll give it the full puck, which is represented by obj, and we'll give it the new name, which we just constructed. So if I run this now, you can see that pcube1 has been renamed to pcube1 underscore geo. And if I deselect it, and let me undo it, and now if I run it, you can see that pcube1 has got the suffix, every joint also has a suffix, and all the groups also have the correct suffix. But like we said, none of the cameras have been affected, and this is exactly what we wanted. This is going to be a small video on how to install PyCharm and get it set up correctly for your system. On the PyCharm edu website, click on download and choose your platform. I'm on Windows, and we're just going to download the Windows version. Once the installer is open, click next. Choose the directory you want it to be in. The default should be fine. This next part is the important one. It'll ask you to choose your Python version. Make sure to install Python 2.7 and not Python 3.5. Maya uses Python 2.7, so it's important that we stay in sync with it. Once that's done, simply click next, and then just continue with the rest of the installer. It'll take a little while to install, and when it's done, you should have PyCharm ready to go. In this video, I'm going to go over how to set up PyCharm edu for Maya. If you're using a different editor, I'll go over the common editors in another video and how to set them up with Maya. But for now, let's focus on PyCharm. First of all, we'll need to set up the Python interpreter. If you go to Configure and Settings, or if you already have some code open, you can go to File, Settings. It'll open up the default settings window. If you go to Project Interpreter on the left-hand side, it'll bring up this panel with a drop-down where you can choose different Python versions to use. What we want to do is use the Maya Python version instead. So we'll click on this little gear icon and say Add Local. You'll have to navigate to where Maya is installed. On Windows, this will be on your C drive or whatever you installed your Windows on. Under Program Files, Autodesk, Maya 2017, bin, there will be an object called MayaPy. On macOS and Linux, this will be in different locations that will be shown in the video. If you scroll down, you will find the MayaPy, and you can select it, and this will tell PyCharm to use MayaPy as its Python version instead. Go back to the gear icon and click on More. Click the MayaPy that we just added, and hit the pencil. Let's call this the Maya 2017 Python, so we know which one we're using. Finally, we need to set up autocomplete inside of PyCharm. If you're using Maya 2015 and below, the dev kit with the autocomplete ships with Maya. using Maya 2016 or Maya 2017, you'll have to download the autocomplete library. On my GitHub page, the dev kits are listed, so let's use the Maya 2017 download. We'll click on the link, and it will take us to the Autodesk App Store. On the Autodesk App Store, you can download it by going to the right and clicking on Download. When this is done downloading, you'll be presented with a zip file for your OS. Inside the zip file will be the dev kit base. You must find your Maya install directory. Again, this will be on Windows under C. It'll be in your program files under Autodesk, Maya 2017. And all you need to do is extract all of these into that directory. Just into the root of that directory, not into any subdirectory. If you're using macOS or Linux, again, the path will be different, but I'll mention it in the video. Once those are extracted, open up your PyCharm settings again. Click the little icon at the bottom right. You'll be presented with a bunch of paths for Python to use. We're going to add one, so click on plus. Again, you'll go to C, and you'll navigate to the directories we just extracted. So you'll go to Autodesk, Maya 2017, and we'll go to the dev kit. Inside the dev kit, go to Other, PyML, Extras, and Completion. Then click on Py, the PY, and then just add this directory by clicking OK. Finally, simply click OK, hit OK again, hit Apply. Now PyCharm will know to use the Maya Python instead of your system Python, and will be able to autocomplete as you type. So let's close down these settings, and I'm going to click background so it doesn't take up my time, and we'll open a project. We'll go to your documents, where your Maya scripts are stored. This will be different on macOS or Linux, but again, I will make sure to mention it. We'll go to Maya, your Maya version 2017, and we'll open the scripts directory. I'm going to click OK to open it up. I'm going to expand my PyCharm, and for the rest of this course, I'll be using PyCharm in presentation mode, so you won't see most of this UI. But for now, if I expand this, you can see our object renamer example over there. If I double click it, it will open up, and you can see all our code from Maya inside here. As I showed in the previous example, whenever I source a script by either clicking Source Script and choosing the script, or importing it, it runs immediately, renaming our scene again, which is not what I want. So let me undo this and shift back to PyCharm. In PyCharm, you can see all our code that we previously wrote. What's happening is, whenever Maya imports or sources our script, every single line of code is going to run from top to bottom. This isn't what we want, because we don't want it to run when we import. This means that we can never reuse our script easily. So what we're going to do is put all of our code inside of a function. To create a function, type def for define, and then the function name, in this case rename. And we'll give it parentheses to say that it is a function. Finally, we'll put a colon. And like everything else in Python, the scope is denoted by indentation. So we'll select everything that we've previously written and hit Tab. Tab will indent it underneath our definition of the function. That means that all of these things will only run when the function is run. Our function is created by the word def for define. This is the name of the function, rename. The parentheses are what we use to show what parameters our function will take. In this case, our function takes no parameters, so we'll just have the empty parentheses, followed by the colon, and then followed by all our code. Back in Maya, if we import this again, nothing happens this time. But we now know that our object renamer example is a library with the rename function inside it. So if we run it, it'll say module object has no attribute rename. That's because Python is trying to be efficient. It knows that we've already imported object renamer example, so it won't try to import it again. Instead, what we need to do is tell it to reload it. So we'll say reload object renamer example. I don't know about you, but that's a pretty long name to type, and we've already typed it 3 times. So what I'm going to do is I'm going to nickname it. I'm going to say import object renamer example as ORE, short for object renamer example. Then instead of saying reload object renamer example, that's a mouthful, we can say reload ORE. And over here we can say ORE.rename. And when we call this, you can see that it runs, and it renames all our objects again. This is your first function, and this will be it for this video. In the next video, we'll go over how to make our function more robust. Back in PyCharm, our first step will be to make sure that if the suffix is already on the end of the object, that we don't rename it again and double add the suffix. This is simple. Because the object type is a string, we can say if obj.ends with suffix continue. And you can see PyCharm is auto-completing as I type. PyCharm has really powerful auto-completion, which is why I like teaching with it, because it's really useful if you're a beginner, as well as if you're an advanced TD. Anyway, I'm saying if object ends with suffix, we will continue and skip the rest of this logic, including the step where we rename the object. This means that if the object does end with it, it won't have 2 times the suffix every time we run this. So if you go back to Maya and run this function again, you can see that it doesn't affect any of these objects. But if I create a new cube, let's move it out here, which doesn't have the suffix, and now I run this, you can see that it's added it just to that cube, because that cube didn't have it before. But if I run it again, it won't add it again. This is our first advancement in the script. Our next advancement is that I want to add more suffix types eventually. But this if statement's already getting pretty long, and if we add a new one for every single object type, it's going to get kind of crazy. So what we're going to do is we're going to make a dictionary where we can define all the suffixes that we want. So we can type suffixes is equal to make a dictionary, we'll make curly braces. The reason I'm making this capital letters is because it is outside of a function, and usually it is nice, though not necessary, to make variables that are outside of a function or any other scope to be capital letters. Inside of this suffix dictionary, we're going to create a new key called mesh. We'll say colon, and we'll make mesh equal to geo. Next, we'll create a joint type, and we'll say the joint will have a JNT suffix. We'll make a camera, and we'll say the cameras will have none. I will explain this in a bit. Next, I'm going to make a default suffix, and I'm going to call this default suffix group. Now down here, the problem is I have to say suffix equals this, suffix equals that, multiple times. What if I make a typo? I'm typing the same logic multiple times with small variations. Ideally, I would just type this once and just use that so I don't have to keep repeating myself. So let me get rid of all these if statements. Instead, we'll use the dictionary that we just defined to look up the suffix. So we'll say suffix is equal to suffixes, our dictionary, and we'll say get, because we are trying to get a value from the dictionary. Now get takes one value by default. As you can see, PyCharm is telling us the key, and we'll use object type. The second key is the default. If the dictionary doesn't have the key that we asked for, it'll give us the default back, in this case none. But what we actually want to do is get back the default suffix. Default suffix is equal to group. What we're saying is, if the dictionary doesn't have the object type we've asked for, let's just assume it's a group and get the default suffix back. But you'll remember that I said camera is none. And this is because I don't want to put a suffix if it is a camera. So what I'm going to do is I'm going to say if not suffix, continue. And what we're saying is that if the suffix is not true, this is shorthand, we'll say to continue and skip the rest of this logic. Therefore, for the camera, the dictionary will give us back the value none. And none is not true. So we're going to say to continue. If we go back to Maya, and if I run this again, it will say invalid syntax on line 2 of my code. And that is because I missed a comma here, and you can see that PyCharm was highlighting it. Again, if I remove that, you can see that it says it's red. If I add the comma, it says it's fine now. I'll go back to Maya, and if I run this again, this time it works. And you can see that everything works alright here. If I create a new object type, let's say create lights, ambient light. Ambient light is of type, let us see, the ambient light is of type ambient light. If we go back to PyCharm, I can add the ambient light type here, ambient light, and I can say that I want it to be LGT. If I go back to Maya and I run my script, you can see that it's renamed my ambient light with a new LGT suffix that I provided. And you can see the advantage of using this dictionary to maintain it, because I don't have to add another if-else statement for each single suffix. It cuts down on 2 lines of code for every single suffix. That's a lot when you add a lot more object types. The next thing we want to do is make sure that our function can be told whether to use a selection or not. So we're going to add a parameter to our function. We're going to say the parameter's name is selection is equal to, and we're going to say that it's false by default, so that it doesn't use selection by default. That's a bit annoying because selection is already used as a variable name here, and this parameter name will be passed down into the function. And you can see PyCharm is highlighting every use of this variable now, and that's not what we want. So I'm going to select this word in PyCharm, right-click, refactor, and I'm going to rename it. And I'm going to rename it to objects. And you can see that PyCharm has found every instance of that variable and renamed it. But it's also grabbed this one, so I'm just going to rename this back to selection. And what we're going to do is say objects is equal to commands.ls selection equals true. This is what we had before. But instead of using the hard-coded value of true, we're going to use selection as our input. By default it's false, but if a user provided true, then selection here will be true, and it will be true here as well. Again, we're only interested in DAG objects, and only in the long names. That means we can get rid of this. But what if the user has said selection equals true, and there is no selection currently. But what we need to do is error early so that we don't run the rest of our code, because the rest of our code can take a lot of time to run if we have a lot of objects. So let's error out early. We'll say if selection and not objects. And what we're saying is that if selection is true and objects are not true, and by that we mean that objects are empty, there are no objects, we will raise a runtime error. And we'll say that you don't have anything selected. How dare you? And this is our first error that we're going to throw. We're saying raise because we're going to raise an error. Just like you would raise a complaint against someone at work for having smelly feet, we're raising a runtime error, saying that we've encountered an error during our runtime. And then we give more details about it. You don't have anything selected. How dare you? I'm going to save this and move back to Maya, where if I now have nothing selected, but I say selection equals true, and I run this, you can see that I get a runtime error from our script. It tells us which line the error is on, where the script is, and it helpfully tells us the error that we gave it. You don't have anything selected. How dare you? Let me select something and run it again. This time I don't get an error. Alternatively, if I say selection equals false, that's the default. I don't actually even need to say this. Let me remove it. And it will run with selection equals false by default, and it will run across everything. Back in PyCharm, the next thing that we need to do is change how this formatting happens. This is alright, but we have 2 plus symbols and multiple strings. This is kind of inefficient in Python. A better way to do it, and it's slightly more complex, is with a %s symbol. It kind of looks like a weird emoji, but what we're doing is doing a string substitution. So we're going to say new name is equal to %s underscore %s, and then we'll give it a % symbol, and we'll give it the short name and the suffix. And the reason I'm showing you this is it doesn't make as much sense for a short string, but when you start doing it a lot and over many objects, the other way of doing it can get really heavy, but this is a really light way of doing it. So what's actually happening is, this %s is being replaced by short name, and this %s is being replaced by suffix. In the end, it creates the same string, but this is a little more efficient, and I'll be using it for most of my examples, so I think it's a good example to show right now. The other thing is, if the object ends with suffix, it might actually be a valid object name and needs a suffix added. What we actually need to do is check if it ends with the underscore and the suffix, and this will mean that it doesn't actually have the proper suffix. Just like the Maya commands give us back a list of objects that they ran on, it will be nice if our object can do the same. At the end of our function, outside of our for loop, I'm going to say return objects. Return objects is going to tell our function that when it's done, it should return the objects list that it has. But the problem is the objects list doesn't represent the new names. So let's change that. Let's get the index of the current item from the objects list. We'll do this by saying index is equal to objects.index of our current object. What this does is it gives us back the index value of the object from our objects list. So if it's our first object, we'll get back 0. If it's our second object, we'll get back 1, and so on and so forth. We'll use this to know what object to replace inside of the list. So we'll say objects index is equal to, and now we'll replace the object inside there. So we'll say object.replace, and now we'll replace the string so that it has a new name inside. So we'll say object.replace short name, new name. And what this will do is, in the objects list, at that index point, it will replace it with the object name, where the object name has had the old short name replaced with the new name. So that means our list will have all the objects it operated on. Anytime that we've renamed an object, it will have been replaced in the list with this new name. So if we go back to Maya, say print ore.rename, you can see that I get a list of all the objects back with their new names, as well as the objects it hasn't renamed with their old names. Finally, we need to make sure that our function is easy to use. People using our code library don't want to be looking at our code just to know how our function works. If I say print help on this function, it gives me nothing back because there's no help for this function. How do we provide help for a function? This is simple. We call it the docstring. First of all, inside of PyCharm, let's change the docstring format. Let's go to File, Settings, and inside of this, I'm going to go to Tools, Python Integrated Tools. I'm going to change it from restructured text to Google. Google is a lot easier to read than restructured text. I'll click OK, and I'll go back to my function. After our function, I'm going to hit Enter, and type in 3 double quotes. 1, 2, 3. And then I'm going to hit Enter. And you'll see that PyCharm's automatically filled it out a bit. This is called a docstring. The first comment after a function with triple quotes will be what's presented when you call help on a function. So I'm going to say, this function will rename any objects that have the correct suffix. You'll say for our selection argument whether or not we use the current selection. And for returns, we'll say a list of all the objects we operated on. If I go back to Maya and I rerun the help command, you can see that I now get the docstring that we wrote. It says this function will rename any objects to have the correct suffix and gives us information on how to use the function. This is a form of documenting your code. Docstrings are really helpful when other people have to use your function, or even if you're using your function down the road and you forgot how you wrote it. This is a form of commenting. The other form of commenting in Python is with the hashtag. This isn't like Instagram or Twitter. Instead, these hashtags represent the intent of the code. So if I type a hashtag, and then I can type anything after it, and these will not run with the program. They're simply there for other programmers to look at. So I'm going to say hashtag, this function cannot run if there is no selection and no objects. The point of comments is that later, when you have to look at your code, or someone else has to look at your code, they don't have to read every single line of code to understand what you were trying to do. It's really useful as well for yourself, because you're bound to forget how your code works. I recommend adding comments to your code so that it's easy to follow along. All my code in the GitHub repo for this project will be documented with comments on how to use it, what I'm doing, and how it runs. You now have a function that can be reused in other projects, as well as called on its own to organize your scene inside of Maya. In our next project, we'll be looking at how to create geometry procedurally. A common task to do in Python is creating strings. For example, let me create a string that says, hello, my name is throat, I am 26. But I want to change this so I can use different usernames and a different age. So let's create a variable for user, and I'll call it throat, and a variable for age, and I'll set this to 26. Now what I can do is say, hello, my name is, plus user, plus, and I am, plus age. And if I now run this, it'll tell us that we can't add a string in an int object, so it requires us to convert this integer into a string, and now it will work. But this can get very cumbersome, because we both need to know the type of the variable, and we need to keep adding strings together, which can be kind of expensive to do. Another option is string substitution. So we can say, hello, my name is %s, and I am %s. Then we close the string, we give another %sign, and then we, in parentheses, we give the values to use. In this case, I'm going to say user, age. And what this will do is replace the first %s with the first value, and the second one with the second value, and so on and so forth. If I now run this, you can see that I didn't need to care about my variable type, and it's very succinct to define. We can also do this with name lookups, using a dictionary instead of a tuple. For example, if I say name and age, I can give it a dictionary now with name and age. Oops, sorry, that should be name and user. And you can see that it now works. This form of using string substitution is one that is very popular in Python. Unfortunately, as you create longer strings, it can become quite unreadable. And it's quite often that you'll have string substitution like this, where it's not possible to figure out what goes where. An alternate way to do this is using the format operator. You can say, hello, my name is, and then we give two curly braces, and I am, and we give two curly braces again. And then we say format, and inside of format, we give it user and the age. And it works exactly the same, but this isn't a huge improvement. It's the same number of characters as %s, and we still have the same problem, that we don't know what goes where without having to read the whole sentence. Instead, we can also do something like this. We can tell it which value to use. And we get the same output. But the cool thing is, I can now change my string and refer to them out of order. And say, hello, I am, and my name is, and this is really cool because I can define exactly where my values will go, and it makes it much easier to read and maintain. It also means that I can reuse any of these values. If I just say 0 and 0, I'll just use the first value multiple times. Whereas with string substitution, with the %s method, I have to redefine user multiple times in each use. I can also do this with a dictionary lookup as well. So instead of saying hello, my name is something, and I am something, I can say hello, my name is user, and I am age. And then I can just give these as arguments to the format function. And now if I run it works exactly the same. If you are doing a lot of string construction in Python, in my opinion, using the curly braces is the best way to go, using the format operator. It's efficient, and it gives you a lot more functionality than than using the %s symbol. That said, if you're only using a single value, %s can be very convenient. It is also common to see it used in many Python libraries, like the logging library. This is because it has been around much longer, and these libraries make use of its legacy functionality. For our course, we'll pretty much be using the %s format, but I want you to know about the .format option as well, because it is more useful. And we'll also hook it up to control the intensity of light. In this video, we'll be going over the logic and function scoping of Python. Python follows simple rules for looking at variables. It first looks at local variables. This is variables that are assigned inside of the function or the current scope. For example, this is the scope of the inner function. Anything that is indented underneath the scope declaration. In this case, the function declaration is the scope declaration. So we're saying anything underneath this that is also indented will be inside the scope. And therefore, when you look up variables, it will first look up inside of this scope, and then it will look up in the scope above it, which is this outer function scope. And then finally it will look above that, and then it will look inside of Python itself. So you can see this described here. This is called the LEGB rule. So L is for local, names aside in any way within a function. Innermost variable is a local function inside of inner function. Enclosing function. This means that functions that are outside of this scope can be accessed. So inner variable is a variable outside of this scope, but it is in the enclosing scope. G for global are module level variables. A Python file is called a Python module, and this is outside of any function, therefore it is a module level variable. Finally, you can use built-in Python types, which are just Python variables that come with Python. So let's get rid of the documentation up here. And below this, let's make sure to call our outer function. And now if I run this, you can see that the inner function can access the innermost variable, the inner variable, the outer variable, and the Python global. If I move this out of the scope, you can see that I can no longer access the innermost variable. PyCharm is smart enough to tell me this. If I try running this, it will error. It says it cannot find the innermost variable at any level higher than this. So if I take that out, it will run. Similarly, if I now take this out of the scope of the outer function, you can see it's now unindented relative to outer function. I can no longer access inner variable. If I run this, it will error. So let me get rid of that. And now if I run this, you can see that it works perfectly. Again, this is because we go from local to enclosed to global to built-in. This is what we call the LEGB principle of lookups. For this project, we'll be learning how to create a controller library using Qt. Our controller library will be flexible and will support thumbnails. We can import any of the objects that we save out, and we can also create any new objects we want. In this case, I will save this as the test, and when I hit save, you'll see that it shows up inside of our window. We'll learn how to save data out as JSON files, as as well as load them back into our UI. We'll be using Qt, provided by PySide2 inside of Maya 2017, and PySide in previous versions of Maya. We'll go over the differences between Qt 4 and Qt 5, as well as the differences between PyQt and PySide, and PyQt 5 and PySide 2. I'll also be going over a popular Qt library that's used by Disney, Weta, Sony ImageWorks, and more, that will help us write code that can be used by Qt in both Maya 2017 and previous versions of Maya. In the next video, I'll do a brief introduction to Qt and the different versions of Qt used inside the different versions of Maya. In this video, instead of creating the script inside of Maya's own script editor, we'll instead be using PyCharm to create the script. In a previous video, we set up PyCharm to point to our Maya scripts directory. If you don't remember what this is, you can say File, Open, and go to C, your Documents folder, Maya 2017, and the scripts directory underneath there. If you're on Mac or Linux, I'll make sure to mention where your directories are as well in an overlay in the video. You can see our previous script that we wrote here, the object renamer. But let's create a new script. We'll say File, New, and we'll say Python file. We'll call this Gear Creator, and we'll say OK. And you'll see, because we said it's a Python file, that PyCharm's already added the .py suffix. Next, we need to load this into Maya. So let's write a little print statement that we can use to test Maya loading our script. So let's just say print, and in quotation marks say hello Maya, and save it down. Now go back into Maya and say import Gear Creator and run it. And you can see that Maya has said hello Maya down here. If you run it again, you can see that it doesn't print hello Maya again. This is because Maya will cache the import, so it doesn't have to re-import it. This means that as we're developing, Maya will not pick up our changes. So what we need to do is add the reload statement. So now if we run this, you can see that it's imported it again and run hello Maya. If I go back to PyCharm and change this to say bye Maya instead, and now run it, you can see that it'll say bye Maya now. Let's go over how we actually create a gear. So first, I'm going to go to Create, and then I'm going to choose a polygon pipe. You can set how many subdivision axes that it has by changing it in the channel box. Right now it has 20. We select each alternating face to create the teeth. Then, we extrude them, and this creates our gear. Now the problem with this is, we can't really change how many teeth the gear has. If I change the subdivisions, you can see that the extrude is now getting confused because it's pointing to polygons that no longer exist where they should be. So when we create our script, we'll have to make sure that we can control how many teeth the gear has, as well as how long the extrusions are, and we have to give it the ability to change the number of teeth later on. So let's get back into PyCharm. I'm going to expand my script editor a bit, and I'm going to collapse my channel box. Let's get rid of the script that we already have. We're we're going to import the Maya commands library. So we're going to say from Maya, import commands. And again, you can see PyCharm giving me autocomplete as I type. We're going to create our temporary function. We'll say def to define a function. We'll give it the name, create gear. We'll give it the parentheses, within which we'll give it the parameters. Our first parameter is teeth. We will give it a default value of 10. Our next parameter is length, and we'll give this a default value of 0.3. These are defaults that I think are good for our use case. Inside of this, we'll say print, creating gear, and then I'm going to just give the two parameters that we already have. So now if I run the script inside of Maya, you can see that nothing happens. This is because we're not actually calling this function. Just like we'd call functions inside of the CMDS library, we need to call the function inside of our gear creator library. So we're going to say gear creator dot create gear, and we're going to say teeth is equal to 20. And now if I run this, you can see what happens with default values. We're overriding the value of teeth because we've told it 20 instead of 10. But we keep the default value of length at 0.3 because we haven't specified it inside of Maya. And we can see that the function is clearly running because it prints out the statement creating gear and the two parameters. The number of teeth is the subdivisions multiplied by 2. So let's call this spans. We'll say spans is equal to teeth times 2. Remember, this is an integer, and we can multiply integers with other integers. So now if we say print spans, and run this inside of Maya, you can see that it says 40 because we're giving it the value of 20. I'm going to get rid of this default, and if we run this again, it'll give us a value of 20 because the default is 10. Let's leave a comment so that someone editing our script later can remember what we intended. I'm going to use the hashtag symbol, and I'm going to say, teeth are every alternate face. So spans times 2. Then we're going to create the pipe object. We do this by using the commands.polypipe object. And we give it a parameter called subdivisions axis, and we tell it the number of spans that we want. If I run this now, and I delete my old gear, you can see that we've created a pipe. So let me delete this, and it'll give it a new value for teeth, and I'll say 30. If I run this, you can see that we have that many spans across it. If I open the channel box, you can see that the polypipe has 60 because we have 2 times the number of teeth for our spans. Let me delete this. Next, we need to make sure that we hold on to the transform and the constructor of this. Next, we get a selection of the faces that we want on the side of the pipe. So we say side faces, this will be the name of a variable, and we use the range function. The range function gives us numbers between the first number and the second number. In this case, we're going to say spans times 2 and spans times 3. Let me go into why we're doing this. If I create another pipe, let me create one, and I select every face that we want for our teeth. And again, this is created with a default value of 20 divisions. So if I select these faces, if I type ls-sl and run it, it'll give me the faces back. I can copy this into PyCharm so it's easier for us to see. And when I copy them into PyCharm, you can see that they start at face 40, go to 42, 44, and so on and so forth. Let me get rid of this line. That means if we're starting with 20 spans, our faces start as spans times 2, which will equal 40, and the end as spans times 3, which will equal 60. If I go back into Maya and now run this, you can see that I start at 40, but I'm going up in increments of 1, but I correctly end at 59, which is just before spans times 3, which is what we want. The range value also takes a third argument, which is the steps it should take, which means it'll give us every second number. If I now run this, let me save it. If I now run this, you can see that it gives us 40, 42, 44, 46, and so on and so forth, which are the correct values that we expect. Now let's select these faces. So first, let's clear any selection that we have. So we say commands to select, clear equals true. Then we say for face, inside faces, commands dot select, and we're going to give it a string. And what we're doing with the string is we're going to say %s dot f, and in square brackets, inside the square brackets we'll say %s. And we're going to use string substitution to create the string that Maya needs to select the faces. So we're going to give it the transform and the face. And over here you can see this will be substituted with that, and that this will be substituted with the second value. And what we're also going to tell Maya to do is to add the selection instead of replacing it. If you were to simply run it without the add parameter, what Maya would do is each time it goes for the loop, it would only select that specific face. But what we're telling it to do is to add it each time. So if I now run this, you can see that I've created a pipe and selected every other face on the side, just like we expected. Next, we're going to extrude these faces. Let me delete this polygon here. And back in PyCharm, I'm going to say extrude, which will be our variable name to hold the extrude. I'll say commands dot poly extrude face. This is a command to extrude polygon objects. I'm going to give it a parameter of local translate z. I'm going to tell it to use length as the value of this parameter. And I'm going to say print extrude to see what this command actually gives us back. So if I now run this, and we get an error because I've not typed this properly, because it's not poly extrude face, but what is it? So in Maya, if I actually extrude the face, you can see that the command it ran was poly extrude facet, not face. So let me copy that back and replace it inside of PyCharm. Let me delete this object. And now if we run it, we've created our gear, and we get a list back that says poly extrude face 1. Since our list will only contain one object, let's only get back the first object inside of it. We'll do this by putting the square brackets after calling it, and we'll give the value of 0. Again, what we're doing is we know this gives us back a list, and we can access that using the same accessor method we've seen for lists, which is using the square brackets and using the 0 to access the first element. We then assign all of this into the extrude variable. If I delete this again and run the script, you can see that we now get the poly extrude face 1, which was the first element of that list. Finally, for our function, let's return 3 important objects that we'll need to make use of later. We'll say return, and we're going to take the transform, the constructor, and the extrude node. So if I delete this gear in the scene, and I run it again, but this time I'm going to say print whatever this function gives us. And if I run it, you can see that our function gives back a tuple of the transform node, the constructor, and the polyextrude face. And there you go. We have a function that can create a gear and gives us back useful data that we can use to manipulate the gear in the next video. Before I finish off this video, let's add some documentation to our function so that people can use it easily. After the function definition, put down 3 double quotes and hit enter. And PyCharm should automatically complete it for you. If not, just copy whatever my video says. We'll say, this function will create a gear with the given parameters. We'll say that the args, or the parameters, are teeth, the number of teeth to create, and the length, the teeth. And we'll say it returns a tuple of the transform, constructor, and extrude node. So now anyone calling our function can simply call help on our function and see what it will give us back. And finally, it's important to note that you should not use the parentheses inside of the help, because what this does is it executes this, and then when you run the help, it actually gives you the help for the tuple that is returned by this. Without the parentheses, you're not executing it, and you're just giving help, the actual function, instead. To recap our last video, we've created a function that can generate a gear based on the parameters that we give it. If I'm to run this, you'll get a gear with a variable number of teeth. In this video, we will show you how to modify the gear that you've just created. The function that we created returns back the transform, the constructor, and the extrude node. These will be useful because we need to modify them in the next function. So let's put these inside of variables inside of Maya. We're going to say transform, constructor, and extrude are equal to our function. And if I now run this and I say print transform, print constructor, and I'm going to say transform, constructor, print, extrude. If I now run this, you can see that it says the transform is p-pipe 2, the constructor is polypipe 2, and the extrude is polyextrude face 2. So let's delete these gears. Let's create a new gear. And I'm going to expand Maya. And if we go to the channel box, you can see that the polypipe 1 has the subdivisions axis that we can change to change the number of teeth that the gear will have. But if we change it, you can see that the polyextrude node doesn't know which faces to edit anymore, and we get really funky shapes. So when we change this, we also need to change the polyextrude node. Back in PyCharm, we'll create a new function to do this. So let's create a gear again. And now that we've stored these values, let's put a hashtag to comment it so that we can't rerun this command accidentally. On the next line, let's call a function that we're about to make. We'll say gear creator dot change, and then we'll give it the constructor and the extrude. And what we're also going to give it is the number of teeth. So now we're going to say we want to make 40 of them. So we have the scene. Let's create a new function. We'll say def change teeth, because that's the name of the function we created. It'll take two parameters. It'll take the constructor and the extrude. It'll take the number of teeth to create and the length. We'll print out the constructor and we'll print out the extrude so that we can see that it's getting the right values. And this is a good time to introduce the two types of parameters inside of Python. If you don't give a default value by giving the equal symbol and a value, Python makes them positional arguments, which makes them mandatory. If you call the change teeth function, you have to give these values because they have no defaults, but Python needs to know what they're equal to. However, you don't need to give these two because they already have a default value, which means that Python knows exactly what they're equal to. So if we run this now, you can see that we got the polypipe 1 and the polyextrude face 1. If I remove the extrude, and then I run it, it's going to give us an error. It says change teeth takes at least 2 arguments, and we haven't given the necessary number of arguments. What we're going to do now is change the number of faces on the polypipe. So again, we'll say spans equal teeth times 2. We're going to get the commands dot polypipe. I'm going to give it the constructor. We're going to say edit equals true. And we're going to say subdivisions axis equals spans. So what we're saying now is that we use the polypipe command again with the polypipe that we have. This time we give it the edit flag so that it knows, instead of creating a new one, to edit the existing one. So if we now run this, you can see that it's changed the number of spans on this, but the polyextrude face is all messed up because it doesn't know which faces to accurately extrude. Now how do we see what it's actually using to store these values? Well, if we say polyextrude face, and I'm going to use the list adder command inside of Python. So in a new line, I'm going to say commands. First of all, let me import the commands library. So we'll say from Maya, import commands. And we're going to say commands dot list adder. I'm going to give it the polyextrude face 1. If we now run this, it gives us back nothing. That's because we need to print it as well. If we select this and then run it, it gives us back a list of all the attributes. There are too many to go through, so I'll tell you the one we're interested in. It's called input components, which we can find right here. We can use the getAdder command to see what it's equal to. So we say getAdder polyextrude face 1 dot input components. And if I now run this, you can see that it's equal to the face values that we have. So we can use, just like we use the getAdder command, we can use the setAdder command to set it again. So we'll create a list to store all our faces. And just like before, we'll say side faces is equal to range spans times 2 spans times 3 and 2. Again, this will mean that we'll go through the first face, which will be the number of spans times 2. Then we'll step up every 2 values as given by this. Sorry, this should be spans times 3. This will be the faces that we want, and we're going to change this list to be called face names so that we don't get confused. So now what we'll do is we'll say for face inside faces, face name is equal to, and again we'll use string substitution. We'll say f and square brackets, and inside of that we'll say %s. Because that %s will be substituted by this next value inside these parentheses, which will be face. if I say print face, and I now run this, let me get rid of this. First of all, let me just copy this out so that we can see the values that are expected. But now if I run this, you can see that it's giving us back the names, the numbers of the faces. What I actually wanted was the face name. If I print that out now, you can see that it says F, and then in square brackets the face name that we want. So what we're going to do is we're going to add this to the face names list. So we say face names dot append, and again you can see PyCharm giving us helpful completion, and we'll say face name. So now if I say print face names and I run this, you can see that it's very similar to the list we have here. Now what we're going to do is, like we did earlier, we're going to now set the attribute. So we're going to say commands.setAttr. Again, we'll use string substitution because we don't know what the name of the extrude node is while we're running the function. And we're going to give it the extrude node. And then the next argument it needs is how many items there are in the list that we're giving it. So we'll say len, and I'm going to give it the face names list. And what this will do is it'll get the length of the face names list and give it to the setAttr function. Next, it needs a list of all the faces that we'll be using. So what we can do is expand the face names list. We do this by giving the asterisk, and we say face names. And what this does is, instead of giving it the list of face names, it expands it so that each of them will be a parameter. This is the same as saying F160 here, and then giving another parameter saying F162, and so on and so forth. What we're doing is, instead of giving them each individually, we're expanding it from the list so that we don't have to do it manually. And then finally, the loss variable is type, because we have to tell it what kind of type the attribute is. And we're going to say component list. I'm going to save this, and if I clear out the history here and then run the script, you can see that our gear has been edited to have the correct number of teeth. We also want to be able to change the length, and this is again very similar. So we say commands the poly extrude facet, because it's the command we use to create the extrude. We give it the extrude node, and just like we did earlier with the poly pipe, we say edit is true because we want to edit it, and we need to let Maya know that we want to edit it. And next, we're going to use a short form for the variable we used earlier. We're going to say ltz is equal to length. This is a short form of the local translate z parameter. You can see the short names inside of the Maya documentation. I'm just going to use it here to be lazy. If I now run this again, it works like we expect. I can change the number of teeth to 10 again and run it, and it changes that. And I can change the length to 0.5. If I run it now, you can see that it's extended the length. I can change it down really small. And just like that, we have a function where we've created a gear, and now we can modify the same gear that we created. We'll now be learning about classes. Classes are a way inside of Python to generate custom types. In this case, we'll be generating a type called animal. We create the animal class by using the class keyword, giving it the name of it, giving it the name animal, and then we tell it what to inherit from. In this case, we're inheriting from the Python object, which is the lowest level type inside of Python. This means that animal will take all the traits that object has. We'll learn more about this in a bit. Within a class, we can define methods. These are similar to functions, but they have to live within a class, and they all take self as a first argument. Other than that, they all behave exactly like functions. We create an instance of the animal object the same way we create instances of any other type inside of Python. So if I wanted to create a list, I would say my list is equal to list. I give it the type I want to create, and then parentheses, and then I store it in a variable called myList. So if I want to create a new animal, I can say something like tiger is equal to animal, and give it parentheses. In the same way we created our list, we're creating a new animal instance by telling it the type, giving parentheses to indicate we're creating a new instance, and then storing it in a variable called tiger. If I say print the type of tiger, you can see that it is a class of animal stored inside a main. This is irrelevant right now, but we'll learn about it later. We've learned how to call functions with objects. So earlier, if we wanted to tell something to speak, we would say speak, and give it the object that we want to perform this action on. For example, we've been doing things like saying commands.parent, and then give it an object like tiger. Instead of doing this, where we're passing our variables into a function, Python has something called object-oriented programming. Object-oriented programming lets us perform actions with the tiger object instead of performing actions on the tiger object. So instead of saying speak and giving it the tiger variable, we can instead say tiger.speak. And if I now run this, it will say I don't know how to speak. This is because we've defined this behavior right here. Another aspect of classes is the fact that you can create multiple instances of one. So instead of having speak say I don't know how to speak, let's say my name is, and then let's make it refer to a variable called name. And we'll say name is equal to none, because we haven't defined a name yet. This is our introduction to the self keyword. What this lets us do is refer to an instance of class. So right now if I say tiger.speak, it will say my name is none, because self.name is none. If I create two animals, and I'll say, and I tell both of them to speak, they'll again both say that the name is none. But now I can do something special. I can say tiger.name is equal to tiger, and buffalo.name is equal to buffalo. And if I run this now, you can see that this instance of the animal object will print out my name is tiger, because the speak method is referring to self.name, which is getting set here on this specific instance. This means that we can reuse the behavior of a class while only changing certain aspects of it as we see fit. This gives us the ability to define lots of reusable behavior. We've seen how animal inherits from object, but we can create other types that inherit from animal. For example, let's create a dog. And instead of object, I will tell it to inherit from animal. And I'm not going to define anything here. So let's create a new dog. I'm going to call it Fido is equal to dog. Again, we're creating a new dog instance, and then storing it in the Fido variable. If I say Fido.speak, it's going to say my name is none, because it's using the method defined up here. Instead, I wanted to say woof. So I'm going to now redefine speak, and I will say print woof. And now if I run this, it's going to say woof. And this is because we've redefined just the speak method from this class up here. But if I now say Fido.breathe, even though we haven't defined the breathe method for dog, it's going to inherit those traits from animal. In this case, we define breathe up here, and you can see that it says I don't know how to breathe down here, just the same as it says I don't know how to breathe up here. This is because dog inherits every single trait from the animal object. And this is because we define animal as the base for dog. We can explore this further by saying print type of Fido, and it will say that it is of the class dog. But if we say print is instance Fido of animal, it will say true, because Fido is an instance of dog as well as of animal, because Fido inherits both the dog and the animal traits. If we define more methods on this to override, we can say walk, and I'll say print I walk on 4 legs.